Hello and welcome back to Calculus 1, section 2.2, idea of the limit. Calculus is a study of change, and it mainly talks about three concepts: idea of a limit, idea of the derivative, and idea of the integral. They all do different things. The interesting fact is that both integral and derivatives, well, derivatives first and then integrals, were both discovered and formalized and used before the idea of the limit. And we're talking 150 years before, at least. And limit, however, defines both things. So it just perfectly describes human race, where you figure something out and you use it, and then you learn what it is later, right? So we are going to do this in a right order. So even though limit is the last one to be formally explained and used, we'll learn that first and then use it to properly define derivatives in 3.1 and then integrals in, I believe, 5.2. So now we start with the basic understanding that the limit is what I call a fancy way to compute a function value. Nothing special, okay? The way you say x squared, function x squared, and you plug in 3 squared is 9. Limit will get 9 as well, but in a different way, far more powerful way. So that's what this lecture is about. So limit is a way to compute y value. Much more powerful way. Limit is a way to compute, or limit is the answer to, right, to compute the y value. Now I said the fancy way, right? Compute the y value of the function. So this computing function values this way is far more powerful, more superior than what you know from pre-calculus. And this is where that story of change, progression, and so on will start to develop. So we start with the notion that f of x equals, say, x squared. And then you say f of 3 is 9. Well, actually, let me first go 3 squared is 9. Now, you know that because 3 times 3 is 9. On the other hand, calculus will say limit of x squared, where x approaches 3, is 9. We got the same answer. Now, this one over here is pre-calc 1, where you just plug everything into the function compute. And over here is you have your calc 1. Same thing. Now, when you look at the graph for the pre-calc situation, you have number 3. The way you do this is you are at 3, you go up, wherever you hit the function, you go towards the y-axis, and whatever number it hits is the answer, making this point 3, 9. So pre-calculus deals with this stationary thing where you are at 3 and you just look where is the reflection, right through that function, where is the reflection towards the y. That's it. Calculus, however, is going to do far more than that. So here's what's happening for calculus. A much bigger graph because we need it. And I'm going to say, let's say right here is 3, which will make this 9. I know it's not to scale, but such is life. All right. I'm going to read the limit statement one more time. Limit of x squared as x approaches 3 is 9. That phrase x approaches 3 is bringing motion into this mix. So I'm going to approach 3 from the left. How do I approach 3 from the left? Well, I go 1, 1.5, 2, 2.5. It's how you approach things. You walk towards them, closing the distance. So you look at this, and it goes like that. So now you say, all right, what is happening on the graph? Well, you will be actually on the graph experiencing this motion. Because if you're here, then you're there. If you're here, you're there. If you're here, you're there, and so on. So you see that as you are moving your x towards 3, the x coordinate of the point on the graph also moves. And then you see that the same is translated for the y motion. I'll give you an example. This point will go here, will bounce there. This point will go here, will bounce there. And you can see the progression happening where the closer you get to 3, you are going towards the black line. So no matter which point you pick in your progression, so these arrows are kind of showing you how all of the points move. So you pick a point, and as the closer you get, the motion is translated this way, in terms this way. So they all kind of move at the same time. Now that you can see in the software. That is $100 when you use that media textbook, because they have slides and you can move things there. The same is happening from the other side. And you see that you converge to 9. So as all of the points that are left of 3 and all of the points that are right of 3 move together towards 3, everything squeezes together into 9. All of these motions happen simultaneously. And no matter where you pick the point, once you are observing a single point, it's pre-calculus. When you are observing the motion of the whole thing, it's calculus. So this arrow here is introducing the change, the motion. And as the point moves towards 3, moves towards this point, moves towards 9, as it moves from this side, we'll be moving down, we'll be moving here, and they converge at 9. And the major theorem in this section says that if the motion from the left and motion from the right, when they agree on a y value, then you have the limit and it's that y value. So how's this better than pre-calc? In pre-calc, it was like, yeah, just plug in 3. Exactly. Calculus. Deeper register, all right? You compute infinitely many values, not just one. You compute this one, and 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 this one. There's infinitely many of these, right? And this procedure never computes at 3. It computes at infinitely many points before 3, infinitely many points after 3, all of them leading towards 3. They never compute at 3. And you go, but I'm interested in 3. Yes, and you can use pre-calculus for that. But what happens if the point is not there? If the point is not defined? Pre-calculus can only cry because it can't be computed. Where this one says, well, I'll extrapolate because I'm the boss. I don't care that the point is not there because I'm not computing at that point. I'm going to compute infinitely many points before and after and just say common sense is that that's what it is. You know, if a bridge is broken in a little segment, pre-calculus cannot fix that because that portion of the bridge doesn't exist and pre-calculus can't do it. Calculus can, because you get workers to approach from one side, workers to approach from the other side, and then they fix that part that it's not there. That is the power of calculus. So we are going to see that the limit of 1 over x squared is infinity at 0. Pre-calc can't do that because you would go 1 over 0 squared. All you can say is does not exist, not defined. Pre-calculus will not be able to deal with that situation. Limits will say plus infinity, and you have the answer. Yeah, you can't do much with it, but at least you have answer, and you can understand certain physical aspects from there. Guys, there is no technology of any kind, no physics without calculus. You can't understand gravitational force without it. Gravitational force between two objects, gravitational constant mass, one object times mass of the other object divided by the distance squared. What does it mean as two objects that have mass converge to the same point? Mathematically, it says it's the infinite gravitational attraction. Does that mean that my heart, which is in my body, or actually, oh, I don't know heart. I know I have a liver. So a liver that is in my body, the liver that is in my body is in my body. Does that mean that the gravitational force between my liver and my body is actually infinite? Because they are in each other? See, these are kind of questions, right? You don't have to worry about it between Earth and the Sun because they have their separate masses and they're distance apart, and then, you know, physics works like this. But what happens at smaller levels, right? Talking about singularities and stuff. So, in order for you to understand how the world works, you have to learn calculus. Well, there are also some other books, but they also have fun stories. You know. So, learn calculus. The idea of the limit is as simple as you're approaching from the left and right. I call that Romeo and Juliet, right? And in some problems they're happy, and the others they're just sad, right? Because, like, let's do the sad example for them. Here, 1 over x. That will be the sad example. So y equals 1 over x, and we want to take a look at the limit as x approaches 0 for 1 over x. I mean, this is featured in a story. This is exactly what happened. So here's the calculus explanation of Romeo and Juliet. Just want to... this is the ending. If you haven't read it yet, spoilers. So we are observing 0, which is in the middle. And as the Juliet approaches 0 from the left, she becomes infinitely negative. And as Romeo approaches from the right, it becomes infinitely positive. And they become infinitely far apart. It's apart when they drink poison and die. So just work it out, okay? Kids. So in this case, there is no limit. We say does not exist, DNE. Because they did not converge to the same point like they did before, at 9, right, 9 p.m. In this case, infinitely far apart. So the limit is, again, a y value. And you observe here that at 0, your 1 over x has no y value. Nothing crosses y-axis anyway. So you can't compute the value for this one. Now your pre-calculus will say does not exist because you can't divide by 0. You just go 1 divided by 0 and it goes error, right? And calculus will give you the same answer. But then there will be those cases where calculus will give you answer where pre-calc can't. And no other way around, which is why calculus is the upgrade. Why the limit is the better and fancier way to compute things. So here is the idea from before. Say you're missing a piece of data in your research. Limit is the one that will tell you what that piece of data is. Because if that's a C, and then that's going to be f of C, obviously, limit of whatever this function f of x is, as x approaches C, is going to be that f of C. Now, the difference between people who don't know calculus and people who know calculus is going to be vastly different in terms of the workforce. Because a pre-calculus person or algebra person will just say, well, I don't have the data. But you have the function and you have the limit. So approach from left, approach from right, converges there, and that's the piece of information you need. Even if you are missing that particular data file, whatever it is, whatever discipline, whatever. So now, how is this computed? It's computed simply by calculating a lot of points before and after the point of interest, and never computing point of interest, because this situation can happen, this situation can happen, and so on. So we have 3 approaches to compute limits. Graphical approach, which is what we reasoned up so far. We have charts and tables, which is what we're going to do now. And then 2.3, analytic way, which means calculating limits in certain scenarios without using charts, tables, and so on. But charts, I mean, the tables of values, will be the go-to whenever you get stuck. And we'll talk about that. So I'm going to just go with a very simple limit of 2x plus 1 as x approaches 2. And you all know what this number should be. Very good. So yes, the answer should be 5. And we are going to learn in 2.3 that when nothing fancy is happening, you can just plug in 2 times 2 is 4 plus 1 is 5 and you're done. But you know, if stuff happens, then algebra, if that doesn't help, it's going to be this. So what I'm going to do now, I'm going to do the chart. I'm going to try and figure out what the limit is by computing, let's say, 3 values before and 3 values after 2. So before 2, let's say we start at 1.9, then go to 1.99. So first you have like $1.90, then you have $1.99. That's closer to $2. And then you have, like on a gas station, right? 1.999. You have that 9/10 on the price. So you see that I am approaching 2. This is actually me walking on a line, going. This is the Juliet approach, right from the left, the red one. And then we have Romeo on the other side, who was 10 cents away, and then there is this 1 cent away, and then 1/10 of a cent away. You just compute these. You plug these values, right? Because you are allowed to plug all of the values, any value in, other than the value you want to compute for these charts. So you plug these in. All right, so 1.9 times 2 is very good, plus 1, awesome. Then the next one, 1.99 times 2. Okay, very good. 4.98, very good. Awesome. Guys, use the, I was about to say use the force. Use the language, okay? Use the language. Read these things out loud to yourself to understanding and catch it like this. Listen to the language. As x values go to 2, where do the y values go? Where do they go? To 5. See that? They go to 5. 4.8 is like $4.80, and then you have 98 cents, which is closer to 5, and then you have 99 cents and 8/10 of a cent. That's actually how they price the gas, right? With that 9/10, it's always 1 cent more than what you see. Ask them for change every time. So we have the same thing happening on the other end. 2.1 times 2 is 4.2, plus 1 is 5.2. 5.02, 5.002. You see that you were 20 cents away over here, 2 cents away over here, 2/10 of a cent over here. So you see that from this side you are growing, the numbers are growing into 5. On this side they're diminishing into 5. They're all pouring and pointing towards 5. So what is the limit? 5. Everything is screaming it's 5. Did I ever use 2 to calculate that? The answer is no. And that's what the power of this is. If you don't have the value for that one on your records, you can extrapolate that from looking at the limit from left and the right, and they converge to that common number. Now, if you try to do this for your 1 over x, you immediately see that these numbers don't converge from both sides towards 5. I'm going to put here Juliet, red, Romeo, blue, and they are both agreeing that they should be at 5. Now, the other example was limit 1 over x as x goes to 0. We know that this is not going to work, but then I want to see it for myself. So what I'm going to do, again, 3 numbers on each side. You can do 15 if you like pain, it's okay. I'm not going to limit you in any way. So we have, let's go negative 10 cents away, negative 1 cent away, negative 1/10 of the cent away, 10 cents away, 1 cent away on the right, 0.00, 10 cent, 10th of a cent away. Cool. Let's start computing. This would be negative 10, negative 100, negative 1,000. On the other side, 10, 100, 1,000. Do we see how these go wee down to negative infinity and these go wee up to positive infinity? They will not agree. They will not agree. As you're getting closer to 0, the value grows either to negative or positive infinity, depending from which side you're approaching. And they're not going to settle at the common spot. Since we are on a flat surface, the positive and negative infinities are 2 different concepts. So, what's happening? No limit, no y value. So, these do not match. Thus, have you ever used the word thus? Use the word more. It's an awesome word. No limit. In a previous case, they both match. They're both going to 5. So we're just going to hang out there at 5. Now, I like to call this a middle school approach because when you learn graphing for the first time in middle school, the way you learn it is you get the set of x's, you compute y's, you plot the points, you connect the dots. It's like a coloring book, right? In this case, it's the same idea. You will always have to get this piece of information so you know what's going in the middle. You come up with these numbers on the side. And it's just like in a middle school. You pick x's, you compute y's, you have the formula to compute y's. And look at the trend. Do they go towards the same point, like they were going here, converging into 5, or they're going to go apart from each other? And technically, that's it. I hope you're not disappointed, but that's the mechanics of a limit. Nothing special, nothing scary. Limit is the y value of the function, and we are computed in this really awesome way, where you compute infinitely many points before and after the point of interest. Pre-calculus computes at the point of interest. So these 2 methods complement each other. Where pre-calculus has no answer, you use the sledgehammer, which is limits, right? If you have to put the painting on a wall, right, you can use the little cute hammer and just go tick, 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 right? You can't split your concrete block with it. That's when calculus comes in. So we restart the stream and talk about the last way of figuring out limits. Oh, actually, let me just one more thing for graphing. So sometimes, right, we use sometimes we use graphs to determine what the limits are because you memorize the graphs. For instance, I ask you, what is the limit of inverse tangent of inverse tangent of x as x goes to infinity, right? And for something like that, you're not going to go and try numbers, right? Because what's 1 cent away from infinity? Infinity, exactly. Or ask Chuck Norris. No, I'm serious. He's the only one who can count to infinity. Twice. In 5 minutes. This is the part where you draw the graph for inverse tangent, which you memorized because, yeah, you know that graph. And you see that as x goes to infinity, where does the y value settle? Exactly. You will have 6 days to memorize this graph. I didn't say this. I gotta put this in a syllabus. Any formulas or graphs that you permanently tattoo on your body, I will let you to cheat off of it on the test. I will not report you to the dean. So if you are to go and just tattoo right here the inverse tangent graph with like pi over 2 and negative pi over 2 and everything, you can use it. It's fine. None of that washable stuff. It has to be a legitimate bill with, like you love it. You gave $100 for that, and since you invested money, I will let you use it. That's technically pay to win. Okay. It goes for any formulas we cover in class, like a product rule, quotient rule, chain rule, anything. Feel like it should be on your forehead? Just bring in a mirror. I don't care. It's like, cool, what's that? It's the product rule for my Calculus1 class. Cost me $70.
I actually have a buddy with a quadratic formula tattooed on him.
See, he'll be able to cheat in my algebra class. E to the I, okay. We don't use that in any of the classes at RV, but yeah. Anytime. So, we cool? Right. So the answer is pi over 2. Why? Because that's the y value answer. That's the y value answer. What's happening here? As x's go towards infinity forever, you see that the y value, right, following this line, is going to hit pi over 2. So at infinity, it's hitting pi over 2. Does that mean that infinity is a point? More calculus comes up. Different types of infinities. Let me just stop the stream. So guys, actually, let me draw one more. Decay function. Decay function says, looks like this. So what is the limit of e to the negative x as x goes to infinity? Zero. Exactly. This is the exact function that models, right, with the constant in front of x over there, that models how the drug metabolizes in the body, like Advil or whatever else. How long do you have to wait for all of it to go away? And we are not elves. So pay attention, right? All right, I'll restart the stream for the next.